Hello, everybody. Welcome to our second Tuesday session of 2024. This session is all about substrates and how to manage and track substrates, which are the fifth color and four color printing. We're going to do a series of short seminars to start out the year, all about different aspects of what I'll call secondary variables that greatly affect the print performance of your shop. So these are things that you should pay attention to ensure that you can control the quality of your print and eliminate waste. So with that, we'll go through a few slides, and then we're going to demonstrate how to measure Substrate Inspector and show you how, once you've created a new substrate in ChromaChecker, you can apply it to your production process and track that substrate over time to see how the substrate is performing from a consistency and accuracy standpoint. Because we've had so many customers come to us and tell us that ChromaChecker saved them thousands of dollars because the substrate manufacturer changed the color of the substrate and sometimes the sheen or the gloss of the substrate without telling anyone. And as many of you should know, your curves and your ICC profiles that you build are critical to that substrate. So if anything changes about the substrate in terms of the coating or the color, it can greatly wreck your reproduction. So you want to get it caught, get that substrate variation caught as soon as possible to eliminate waste, and then come back to the manufacturer and hold them accountable for not providing a consistent substrate. So with that, the agenda today is essentially the importance of substrate and how the supply chain issues related to availability and consistency has limited our ability to get consistent substrates over time. Luckily, ChromaChecker gives you the ability to find a best match substrate, which we'll show you, which comes in handy when your supplier tells you, hey, we can't get this anymore, and you're going to go with another substrate. So we're going to go through essentially a 5-step process of checking the substrate. The first is defining what your production standard substrate is. The second is benchmarking your substrates to know which substrates have the same characteristics. The third is how to use the best match function in ChromaChecker to actually find substrates that match the substrate that you want, and then tracking that substrate over time. And then lastly, when you're adding a new substrate, before you go ahead and build a curve or build an ICC profile, ideally you should see how similar that substrate is to your existing substrates to know if you can use an existing curve or an existing substrate versus recreating one. So this is a old Flint ink color book. And Beth, can you let Hossam in, please? This color book is phenomenal because it's actually the same ink film thickness on multiple different paper stocks. And it just shows you how paper is the fifth color in four color printing. And so we need to really pay attention to the substrate when doing our work. So the first step is defining the production standard of your substrate color. And in the ChromaChecker Print Inspector dashboard, you can see this middle column has the substrate listed, and you can put an individual tolerance on the substrate. Hence, you see the on the Iridesce, it's an Iridesce printer, the E factor of the print trying to match crackle is 7 E factor off. So it's significantly off. The majority of customers would not accept this, but the paper is off by 3.2 of the paper's reference. So the fact that the paper's off by 3.2, there's no doubt that the print's going to be off by 7.1. So at this point, seeing this on the dashboard, and ideally companies have ChromaChecker dashboard up on a 70-inch screen on the wall where everyone in the production facility can see it. And of course, a manager typically has it on their wall, on their office. So if you start seeing this, you can say, hey, what's going on with the substrate? There's probably nothing wrong with the printer, nothing wrong with the curves, nothing wrong with the file. It's all about the paper. And this is the number one reason why prints are rejected, is because the substrate's wrong. So the more we can alert the operator that the substrate's wrong before they print a job, the more you're not going to take a big loss on that job because the substrate is wrong. So when we talk about benchmarking our substrates, there's numerous tools that we can use. Obviously, we want to use some sort of spectrophotometer. And today I'm going to be using an i1 Pro 3. You can use it with any of the 10 ChromaChecker instruments that Capture supports. And we actually have methods. So if you have an instrument that ChromaChecker Capture doesn't support, you can still measure the substrate and bring it into ChromaChecker. You should also have a white-black backer. This is our full-size 11x17 white-black backer. You can see by the sheen, it's like a plastic material, so it's really easy to clean. It's ISO compliant for both the white and the black. And when you're measuring substrate, you want both the white and the black to measure things like opacity and things like that to get the real characteristics of that substrate. So this is key. We also have a smaller, like a 3x3-inch version of this. We'll put a special on this for all the attendees. This will be available for, I think we'll sell it for $99. I think the regular is $125, maybe a little bit more. But for anyone who attends this session, we'll give you this substrate backer for $99. We also have a micrometer gauge. This micrometer gauge allows you to check the thickness very quickly. It's like it looks like a stopwatch, but when you push the pin down, it measures how thick the substrate is. Also, gloss meter is important to know the gloss of it, and then a scale to know the weight of the paper. So with all these capabilities, we can really document what the substrate is doing. And of course, if you're printing on unusual substrates like this substrate, which is foil, whether it's got a white backing or not, or this is a wallpaper sample from one of our customers. And if you look at the sheen here, even an i1 Pro 3 will not measure the sheen correctly. It gives you some false values, or inconsistent values is what I should say. And this type of material needs a spherical instrument, which we do support, in order to characterize it, to know how it's performing. Now, in ChromaChecker, we've also implemented this best match function. So if you've got a substrate and you find out the supplier is no longer providing it, you can do a best match function, and ChromaChecker will go in and find a paper in the database which is closer or closest to what the paper you're trying to match is. This is super handy if you're trying to match a proof to a press sheet. And most companies will buy a proof sheet which is aligned with Grackle with like a 94 1 -4 white point, and that's an LAB value that I'm quoting. So it's a 94 L star 1A and -4B. And that's great if you're always printing on a paper that's fairly neutral. But most people don't. Most people print on a paper which has a lot of optical brighteners. So what I recommend is that you align the proofing substrate with the same amount of optical brighteners that the press substrate runs with. So in this way, you can take your press substrate into ChromaChecker, measure it, and then find the closest proofing substrate that best matches that press substrate, and then profile that with your profiling software. And in this way, you'll get a better press to proof match than you've ever done before. Because again, if you align the paper, then the color on top of the paper is going to naturally be easier to match. If the paper's off to begin with, it becomes very difficult. So we've actually documented our math in a 2016 TAGA paper that we partnered with Professor Robert Chung from RIT on. And it's not just delta E. In fact, delta E is the third metric that we use in order to calculate visual best match of color. So it's a very unique mathematical formula that we've put together that works really well, hence the tag of paper that we published. Now, when you do the best match, you'll see that at the top is my paper that I'm looking to match. It's a 96.1 minus 10 LAB value. And then down below, you can see it. ChromaChecker found the 4 closest matches, and it gives you the ratings on those matches. And it actually gives you a visual representation of what it looks like down below in each of the M conditions. So depending upon which M condition you're using to measure color, you can see if we're, let's say, M1 with white backing, that's normal. That's the second set of squares in. And you can see that the substrate 1, which is the reference, is a bit lighter than the substrate 2, which is the first result in the match. So we even predict how close the visual representation is going to look. Now, let's go to our next slide. Once you've defined the substrate, you can attach it to the print track of the given printing device that you're monitoring. And in this case, this is an Inca inkjet printer. And you see that the purple line is showing you the E factor of the printer over time. The gray line down below is the substrate delta E over time. And because the color bar has a substrate patch on it, every time the color bar is measured, whether it's digital or offset or flexo or what have you, ChromaChecker can automatically compare the substrate to the reference of the substrate. At the same time, it's comparing the physical printed colors against the given reference, such as Grackle, that you're aiming for. So in this case, it's really interesting in that the majority of times that this printer has failed is because the operator loaded the wrong substrate. So this becomes really useful in order to, again, eliminate bad color on press and hold the suppliers accountable in terms of ensuring that they're providing consistent substrates related to coating, such as gloss, and color. So these are key. Now, whenever you're adding new substrates, you should intelligently add them to your library so that when you're adding new substrates, you measure them within to the ChromaChecker substrate inspector, and then you can compare. And here you see on the screen, I've got 4 substrates. I click on the check boxes next to them. I can then compare them to one another, and ChromaChecker will tell me how close these 4 substrates are to one another visually, based on their opacity, their white point, their sheen, all of these variables, to know whether or not I can share the same ICC profile between these substrates or if I need different profiles. And when I go through the compare, you can see here which substrates are aligned, which it's more like a green and a yellow set of boxes versus red, meaning they're not aligned. You cannot share or you shouldn't share curves or ICC profiles between those substrates. So this allows you to become very knowledgeable in terms of what substrate needs what curve and what profile. And the ultimate test is doing printed color on substrates. So this is how the ink and toner interacts with the substrate. So by printing any color bar on the substrate, whether it's our CC84 or the 12647-7 or literally any color bar, you can then use this tool in ChromaChecker called Print Condition Qualifier that will show you how close these substrates are to one another, and in this way know which substrates need their own curves versus or ICC profiles, and which substrates can be shared with other substrates using the same curve. So from an administrative standpoint, makes it really easy for the operator to know that they're not having to unnecessarily build different profiles or different curves for different papers. So when we go into the print condition qualifier, you'll see here you set the threshold of how close is close enough for you. And 3 is it's a tight level of closeness in terms of a 3 delta E or 3 E factor. And so it's saying that I've got 5 different substrates. If I want the print to be within 3 E factor of all of them, how many groups do I have? And for these 5 substrates, it breaks it down into 3 groups. So the semi-gloss and the high gloss pharma are in one group, the poly's in one group, and the thermo and the Condura is on one group. So in this way, I know I need 3 different profiles for these 5 substrates. But if I were to change the print condition qualifier to something like a 5, so being a little more lenient in terms of my level of color expectation on the physical printout, matching Grackle or whatever I'm trying to match, if I say, hey, I can live with a 5 E factor, all these substrates fall into one category. So I only need one profile to manage for these 5 substrates, which from an administration standpoint, it means one profile or curve to update. It means one workflow for the files to go through, so it's less for the operator to screw up. It makes things a lot easier. Now, the color is not going to be as good. It's not going to be as accurate because I'm allowing for a 5 E factor versus a 3 E factor, but you get what you pay for. The tighter you want the color, the harder it is. The more workflows you need, the more profiles you need, the more curves you need. The less the tolerance, the looser the tolerance, the less profiles you need. So this print condition qualifier is a really fantastic tool to save you time and money and energy when you're optimizing your color. So essentially, you want to apply the profile, the production standard to your substrates through Print Inspector. You want to benchmark your substrates, use the best match to determine which substrates can share existing curves and ICC profiles. Put individual tolerances on the substrate, which alerts the operator right away. In fact, the software even will tell them, hey, it looks like you've got the wrong paper in here. Stop the production run, check the paper. And then intelligently choose which papers are need new curves. Don't bring on a new paper if you need new curves or new profiles. Ideally, bring on a paper that can coexist with existing curves and existing profiles, and it'll save you energy and time. So with that, let's get right into the software and show you how easy this is. So I'm going into the Capture software. I'm going to log in to my account. And as I log in, you'll see up at the top, I've got a brown icon. That's my substrate inspector. I'm going to click on that. I'm going to say I'm going to measure my substrate on white and black. I'm going to just call this substrate, I don't know what this is. I'll just call it sample 1. And put 1 here, substrate type, it's coated paper. I don't know the manufacturer, but it is for digital and it is for proofing. And I say continue. And now it gives me the ability to measure the substrate. So I'm going to get my substrate out here. I'm not going to measure where there's print. I'm measuring where there's not print. And the first time I'm going to measure 3 times with the white backer. So you see I have the white backer here beneath it. And so the first time I measure, it says, okay, you've measured 1. Now I'm moving the instrument, measuring a second time. Typically, I try not to rotate the instrument when I do this. I want the same orientation. And now it's asking for the black backing. So I turn my black backer over, or my white backer over so it's black. And then again, measure 3 different locations on the sheet. It's all the time giving me the max and average delta E of these measurements to make sure I didn't accidentally measure on, the wrong backing or potentially on color. And then here you see ChromaChecker automatically, even though we just measured 3 times, it averaged those 3 times into one measurement for M0 on white backing and M0, M1, M2 on black backing. And then at this point, it shows you the spectral data here. And then I can set the basis weight in terms of pounds, the caliper, the glossness. These, of course, require separate instruments that we measure. We talked about a scale and a caliper and a gloss meter to measure these things. And then I can say save. And now my sample 1 is saved. And now, if I want, I can track sample 1 over time. So if I just want to track the substrate, I don't care about the print on it, with ChromaChecker, I can go ahead and say add measurement, and I can go ahead and start measuring it. And it will do a trend line for the paper within Substrate Inspector on the cloud. I won't take the time to do that, but I am going to go to the cloud now to go to my ChromaChecker, and you'll see when I go to my Substrate Inspector, I have this sample one, and this sample one is what I just measured seconds ago with you. And you see the data, there's 6 green buttons. The 3 top ones are M0, M1, M2 on white backing. The 3 bottom ones are M0, M1, M2 on black backing. The red button here represents polarization, or M3 on both white and black backing. And the instrument I have here, being just the i1 Pro 3, not the Plus, does not read polarization, so I can't track the polarization condition of this paper just due to the limitation of the instrument. Now, at this point, I can assign it to a printed track. So if I go into my print inspector, and let's say this is a new paper I want for my Epson. The current substrate is proofing substrate inline. I'm going to go in and hit the toolbox here and go here to my substrate library, and I could go in now and change it to sample 1. And now, once I say save, every measurement I bring in from this point forward, it will compare the paper white to that sample 1 that I just measured in whatever M condition this Epson is set up for, which you can see here is M1, and it will tell me what the delta E is in the dashboard. So that's how easy it is to tie, and you see here sample 1, and it shows me the last measurement I did is a 1 delta E different from the reference. And if I go into my magnifying glass here, you can see as I turn off these layers here, I've got a layer here, which is my substrate, and you can see the consistency of that substrate over time. And as we scroll down to the data, in this column, this is the substrate delta E numbers. And so you can now track how close subsequent measurements are matching that color of the substrate that you set up as your production value. Next thing I want to show is the print condition qualifier, because this is something that I think most customers don't use, and it's very underutilized. I'm going to go into my Iridesce printer, and I made a new track, and let's just show you how easy it is to do that. So I'm going to delete this track I made a second ago that had no data in it, and I'm just going to go for the Iridesce and make a new track. So I'm going to say duplicate track, and I'll just call substrate, and we'll say substrate qualification duplicate. Now I've got this track here. Now, just by hitting this magnifying glass, excuse me, it's not a magnifying glass, it's a cloud with an up arrow. I'm going to go to some previously measured files I've got on my disk. And they were all printed on the same printer, but 4 different substrates. And when I open them, ChromaChecker imports the data, and this data could be measured with any tool as long as it's one of 10 different color formats, such as CXF, MXF, CGATS text, any of those, it'll come right in. And now that I've got those 4 substrates in here, I can say select opposite, go to my print condition qualifier, and I'll say my E factor is a 3. And when I say go, it shows me that for these 4 substrates, I need 3 groups. And if I go change my tolerance to be a 5 and recalculate, I still need 3 different groups. If I go to 7, now I need 2 groups. The poly's in one group and these other 3 are in another group. And I can actually look to see, oh, look at that. The poly is 8 delta E different from the other, from the 1. And it's that's why it's out kind of on its own. The poly is very different from the others. So in this way, I need 1 curve or 1 ICC profile to characterize the poly, and then 1 curve or ICC profile to characterize the other 3. So hope this session was helpful for you. does anyone have any questions?
No questions, but I found it very interesting. Thank you.
Thank you, Michael. Thanks for attending. I appreciate it. We like I mentioned, we can measure all types of materials. I'll go ahead and pause the recording at this point, and thank everyone for attending.